Engineers in the modern era have built some amazing structures, and most of the tallest have been erected in the last 15 years. The Burj Khalifa in Dubai is 2,717 feet tall, was completed in 2010. The Merdeka 118 in Malaysia is 2,227 feet tall and was finished in 2023. The Shanghai Tower in Shanghai is 2,073 feet tall and it was finished in 2015. Then you've got the Macau Royal Clock Tower in Saudi Arabia, standing at 1,972 feet, and it was finished in 2012. These amazing feats are a display of modern architecture, engineering, and machinery, but will these buildings make it for the next 4,500 years? I don't know if the odds are in their favor. I mean, when you look at the Great Pyramids, which are only a fraction of the height, standing at 490 feet, they definitely have a leg up in their controversial construction methods. Compared to how we build today, cranes, steel cables, pumps, the wheel, I mean, that alone is huge, right? Versus what the mainstream explanation for how pyramids were built, manpower, ramps, ropes. Khufu's pyramid alone consists of approximately 2.3 million blocks, and they weigh an average of 2.5 tons, which is equivalent to a Cadillac Escalade. And the total weight of the pyramid is about 5.5 million tons of limestone. Plus, you've got the King's Chamber, which is capped with 3 granite blocks weighing up to 80 tons each. And these were lifted 400 feet in the air, right? Keep that in mind. Conservatively, there are 4.5 million limestone blocks that were used to construct all 3 of the Giza pyramids. New York has about 8 million people, and if those people identified as limestone blocks, it would take over half of New York to build the Giza pyramids. Now, I imagine that most of you have seen some type of construction site in the wild, and I'm sure you would be shocked if there were just thousands of limestone blocks sitting around waiting to be turned into something. Luckily, they would have room in the desert to build smaller stacks into larger ones. Now, while there's no real attempt to build a 40-story megalithic monument in recent centuries, there was a project in Nubia that we can use as a reference. Some of you may be familiar with the archaeological site in southern Egypt that's famous for 2 massive rock-cut temples commissioned by Pharaoh Ramses II during the New Kingdom. Abu Simbel was originally located on the western bank of Lake Nasser. The temples were constructed around 1264 BCE, and the statues were rock-cut, meaning they were sculpted directly into the sandstone cliffs of the Nile. The ancient workers used subtractive architecture, carving inward into the mountainside rather than stacking blocks to create the original structures, similar to how the Sphinx was carved from the bedrock in Giza. First, they smooth the vertical face of the cliff, and then they excavate the rooms and carve the colossal statues straight from the rock, basically making the statues in the interior halls part of the mountain itself. Now, this is sandstone, which is 6 to 7 on the Mohs scale of hardness, and that's double the hardness of limestone. So this subtractive architecture was also done with copper tools, supposedly, but the reality on that is copper tools would dull quickly because sandstone's a hard stone, and copper, similar to limestone, is only a 3 on the Mohs scale, which to me would mean that you'd have to have hundreds of copper tools like ready to go to be able to keep up with the demand on these carvings. Again, I'm not an expert. I'm just a dude who is into this stuff, but I also do sell tungsten carbide, and so I'm kind of what it takes for metals to cut other metals, other materials. So I do have a little bit of, some background knowledge and at least the hardness of metals and materials. So that's just something. On the facade of the Abu Simbel temple alone are 4 colossal seated statues representing Pharaoh Ramses II. Each of them sits at 66 feet tall, and the interior is carved about 200 feet into the hillside. It's like imagine digging a tunnel with a spoon. And then you have the famous rebuttal, all they had was time. The interior cavern contains 4 statues, and twice a year on the summer and winter solstices, the sun's rays illuminate the statues of the gods Amun-Ra, Ramesses II, and Ra-HaKatori. They're in the inner sanctuary. So those 3 get lit up, and then Ta, who's associated with the underworld, he gets left in the dark. The temple was also dismantled into 1,036 pieces of stone weighing between 2 and 30 tons. They were precisely cut and transported, moved almost the length of a football field, and then reassembled on an artificial hilltop to avoid major water damage. Modern engineering techniques that could also be applied to building a pyramid. In the 1960s, the construction of the Aswan High Dam threatened to submerge the temples under the rising waters of Lake Nasser. In a monumental global effort led by UNESCO, the entire complex was moved. The official name of the project was the International Campaign to Save the Monuments of Nubia, aka the Nubia Campaign, which you should just go with that originally. The campaign was executed by an international engineering consortium under UNESCO coordination. The temples were cut into the blocks and laid into a cutting grid and then reassembled approximately 213 feet higher and 656 feet inland from where they originally stood. The entire relocation took approximately 4.5 years from the start of the site preparation to the final inauguration. The crew included stonecutters from the Carrara marble quarries in Italy, archaeologists, engineers, and heavy equipment operators from around the world. To move the temples, engineers used a combination of heavy excavation and surgical cutting tools to ensure the reconstruction of the facade looks seamless. And not surgical like when you're going into the doctor. These were large precision tools built to cut hard stone and transport and move these large blocks. Let's get into the process and we'll check out some of the tooling. Here, where the temple originally sat, the entrance was right on the bank of the lake, and if it rose up, it was just going to fill everything and submerge it. So before any construction could begin, they had to put a cofferdam system, which is a massive temporary rock and sand barrier, and that was constructed to keep water away during the dismantling and the reconstruction of the project. After that, they had to basically peel away the mountain using heavy machinery such as loaders, excavators, dump trucks, removing enough rock and sand to fill over 150 Olympic-sized swimming pools. And then finally, before they could start to do anything, one of the most impressive technical feats was the internal shoring. So they had to take the entire interior of the temple, fill it with steel scaffolding and sand, and then that prevented the roof from collapsing as they were removing everything from around it. Finally, on October 15th, 1965, the most experienced stonecutters began the surgical task of cutting the first face away from the rest of the head.
Let's cut to a clip.
And the last block was removed on April 16th, 1966. So 6 months exactly to dismantle the temples into the cutting grid. Electric power saws were largely rejected because they would have left wide visible gaps in the reassembled temple. So to keep joints under about 8 millimeters or roughly a third of an inch, much of the delicate facade was cut using traditional hand saws and steel wires. The cut blocks that weighed between the 2 and 30 tons, which were again roughly the same weight as the limestone blocks built in the pyramids. The precision joints were achieved through methods that would have been recognizable to ancient stonemasons at Giza, with a tiny tolerance of only plus or minus 5 millimeters. Especially on the visible surfaces, they wanted to keep the cuts thin so they could patch everything back together with minimal seam damage. And extra precaution was definitely taken because if you mess something up, you can't just go get another giant stone face. You can't just go grab another block from Home Depot, you know what I mean? So these are one of ones that they're cutting, restacking, moving. So Here you can see the precision grid that was used by engineers to organize the blocks to be reassembled in the right order. Each block had holes drilled into it where the steel bars were inserted and secured with a synthetic resin. This allowed the cranes to lift the blocks without using slings that could crush the corners or damage the stone. The cutting and the removal of the colossal faces was arguably the most delicate phase of the entire relocation. Because the sandstone is porous and fragile, engineers had to prioritize the structural integrity of the living stone over the speed of getting it done. So after the face was fully detached, a crane hooked into the steel lifting bars that had been set into the stone. The face was then slowly lowered and placed on a sand cushion or straw mats for protection during storage. And again, there's only 4 faces. One of them already was ruined, so that's why on the whole thing, there's only 3 and then a half statue because one was ruined before the project started. But again, you can't just go out and get another one made up. I mean, I'm sure you could, but the point is, it's not. This was done in the 60s. It wasn't just readily available. So, again, this is a lot going into just moving these stones already. During the reconstruction phase, the project shifted from a surgical demolition to a high-stakes industrial reassembly. Rebuilding the temples was like solving a 3D jigsaw puzzle. Gantry crane systems were installed near the facade for controlled vertical lifting, and crawler cranes were used to lift the blocks weighing up to 30 tons. The cranes operated on pre-prepared platforms, just sat there and lifted blocks. The original heads were too heavy for the 30-ton crane, so the crowns were cut off first to reduce the total weight before the faces were tackled. And that's interesting to me because if the cranes were having a hard time lifting 30 tons just, a few hundred feet into the air, how were the ancient Egyptians able to lift 80-ton granite slabs over 400 feet in the air to cap the top of the king's chamber? Right? They definitely didn't have, what did they have, 100-ton cranes just laying around in ancient Egypt? There were also flatbed, heavy-duty trucks that transported these blocks inland to the new artificial site. They were shock-absorbing transport cradles that were designed to minimize vibration and damage to the carved-out reliefs. And then to make the seams disappear, the blocks were placed with a tolerance of only 5 millimeters. So if a block was slightly off, it had to be lifted, the base shaved by hand, and then reset, which again is something that would have had to happen in ancient Egypt with the precision of the joints in the pyramids. If it wasn't right the first time, it would have to be pulled off and redone. So, I mean, if you're accounting for that, that's going to add time. Once the blocks were in place, the gaps were then filled with a mortar made out of crushed sandstone dust from the original site, and it was mixed with resin. And that ensured that the color and the texture matched perfectly, so then it could just be sanded flush and look like a single piece of stone. Now, again, the temples aren't just placed on top of a hill to mimic the cliff. Instead, engineers built 2 giant reinforced concrete domes in order to hold the structural weight of the temples. The largest dome spans 197 feet and is 82 feet tall, which is far from the Burj Khalifa, but it's still an impressive feat. The domes, again, are essentially a massive hollow shell of reinforced concrete acting as a skeleton for the reassembled temples, carrying all the weight, which is about 300,000 tons of rock and rubble that are piled up to make the artificial hill look like the original temple. The blocks of the temple are effectively anchored into the concrete structure, and this ensures that the original sandstone blocks aren't supporting any of the weight from the mountain, which will protect them from failure, stressing, cracking, anything along those lines. Once the concrete domes were finished, they were covered again with the original rock material that was removed during the excavation, and it just made the site look more natural. Hidden in the hollow spaces of the dome, basically in between the walls, are mechanical ventilation systems and permanent electrical lighting. And these systems will regulate the temperature, the humidity, and prevent the porous sandstone from deteriorating due to the increased number of visitors. And I find it amazing that the original builders already took all of this into consideration before they even carved it into the hillside. If you recall, the original temple was aligned so that on twice a year, the sun's rays would travel into the sanctuary and light up the statues. So again, this was ceremonial and that was important. So during the project, they used all sorts of photogrammetry equipment to extensively document the entire every carved surface before taking it apart. So these precision measurement tools ensured that the blocks were replaced exactly in their original positions and re-ensuring accurate reorientation to the solar alignment. So between all these precision tools and the cutting grid, everything is able to go back right where it came from. And they were actually so accurate that the solar event still happens today, but it does happen a day later than it originally did because they raised the site up. So still happens just on a day later, which is pretty cool. So in a way, the relocation of Abu Simbel provides some context between ancient and modern industrial engineering. While the Egyptian techniques are still speculated, the 20th century UNESCO team moved a literal mountain under extreme pressures. And altogether, the Nubia campaign successfully relocated 22 monuments and architectural complexes that were threatened by the construction of the Aswan High Dam. Due to the massive success of the project, it also kicked off the UNESCO World Heritage Sites program, identifying and protecting over 1,000 cultural and natural sites of outstanding universal value. So while the UNESCO teams used massive cranes to lift 30 tons, they did only move about 0.5% of the total blocks that are found in the Giza pyramid, which means while our individual lifting capability has grown, the volume and speed of stone setting still hasn't really improved since the ancient times. I mean, if you think about it, Abu Simbel took about 4.5 years with modern machinery, and they did less than 1,000th of the work. So Giza was supposed to take 20-ish years, and they did that without any of the modern accompaniment, let's say. Um, so I mean, it leaves a lot of questions. Again, without anything being found, it's just hard to really say what was done to shape these blocks, move them, lift them. But again, I mean, to do all that in 20 years, even just Khufu's pyramid is 2.5 million blocks in 20 years. I mean, that's around the clock. They had a rotating labor force, sure, but that had to be 20 to 25,000 people constantly working, and then there's no records. You have 25,000 people constantly rotating in, and nobody wrote about anything. They never found any writings in villages, any sites past the pyramids. So, I mean, to me, that's kind of weird. And just, but again, that's not what this is. This is really more just about what it takes for modern engineering and machinery to move these large stones 2 to 30, 50, 80 tons, and how they and how are they doing this with copper tools? Again, copper is only a 3 on the Mohs scale, so effectively against limestone, they're roughly the same hardness. So that's fine. It would possibly happen on limestone. We can give it that. But against the sandstone, if they're using copper tools to do this, and sandstone's triple the hardness, they're going to wear that out quickly. I mean, it's just you're grinding copper against sandpaper. And I mean, I don't know. I think what I've come up with is that the limestone started out as boulders, and they just, as they were dragging them across the sand, it just shaped it into rectangles, friction acting like sandpaper. And they just basically rotisserie rolled these blocks across the desert until they were perfect. I think that's the only thing that makes sense anymore. Um, I hope you liked the video. Hopefully you learned something. I don't know. This is just a thought I had. Like I said, I'm not a archaeologist, a scientist, a scholar, just a guy who thinks that ancient cultures, ancient history is fascinating. And I definitely think there's something out there that we're not putting together. Um, and if this isn't for you, then fucking click on, bro, and find something else. It's fine. But hopefully there's, some more videos to come. And if you liked it, hit the like, hit the subscribe, help us grow, stick with the community, stay curious.